Hey Calc students, welcome back. Let's do number 7 from the extra set of problems that I created. And the things I created are things that have been recently emphasized and they're fair game for the upcoming test. Okay, so let's see. Let g of x be a function that is differentiable for all real numbers. You are given that g of 3 equals -1 and g prime of 3 equals 0. Oh, sorry, that shouldn't have wrapped around on the line like that. G prime of 3 equals 0. Okay, so we're given this function g. We're told it's differentiable for all real numbers. And the function f is defined to be g of x for -2 less than or equal to x less than 3. And it's defined to be this quadratic for x greater than or equal to 3. Okay, first off, the domain of f is everything from -2 to infinity. Prove that f is continuous on its entire domain. Well, let's start with the interval. Let's start with the interval -2 to 3, not including 3, because that's just determined by g. Well, since g of x is differentiable, then g of x is continuous. For all real numbers. When I say g of x is differentiable with no other qualification, we assume that just means over its entire domain. But they told us it's differentiable for all real numbers. So since it's differentiable for all real numbers, then it's continuous for all real numbers. Okay. Thus, f of x is continuous on the interval -2 to 3. That's enough because g is differentiable on g is continuous for all real numbers. Therefore, g is continuous on -2 to 3, including -2, not including 3. We haven't figured out 3 yet because that's the breakpoint between the two parts of the piecewise. Okay, what about the interval from 3 to infinity? Well, we got to be careful not to include 3 because we got to do that one separately. For 3 to infinity, since negative x minus 3 squared minus 1 is a polynomial, you can just state this without saying anything more. Then it is continuous on the interval from 3 to infinity. Thus, f is continuous on 3 to infinity. Okay, so the only point left to discuss is 3 itself. So let's do the full workup of the definition of continuity at x equals 3. What is f of 3? It is -3 minus 3 squared minus 1, which is -1. Okay, that's one part. So we've done one thing. What's the next thing we need to do? We need to do the limit of f of x at x equals 3. Well, let's do the limit from the right first. The limit as x goes to 3 from the right of f of x, but that actually equals f of 3, which equals -1. Now, why? Because f of 3 is in this part of the graph, so this limit is just direct substitution into this, but we already calculated that. So the right limit equals f of 3. But we also need to look at the left limit. Well, let's, sorry, I'm slightly running out of room over here. So we, let's do limit as x goes to 3 from the left of f of x. But that is the limit as x goes to 3 from the left of g of x. Now, what is this limit? Well, g of x is differentiable, therefore it's continuous. We've already said that. Since g is continuous, the limit at g already exists. It's continuous for all real numbers, so it's continuous at 3. G is continuous at 3. So this is just g of 3. When a function is continuous, you can do direct substitution on the limit. So that is just g of 3, and they told us in the setup that g of 3 is -1. Okay, so since g is differentiable, then it's continuous. Since it's continuous, then the limit exists at every point in its domain, because it's continuous at every point in its domain. And part of continuity is that the limit exists at all the points where it's continuous. So we've got that. Therefore, the left limit, the right limit equals -1. The left limit equals -1. Therefore, the two-sided limit equals -1. You have to state this. And we have finished the second step. This was step 1. Getting to this was step 2, which took a couple steps to get to that part. And then finally, 3. The limit as x goes to 3 of f of x is equal to f of 3. Therefore, f, give myself a little bit more room. Therefore, was it capital F? No, small, some lowercase f. Therefore, f is continuous at x equals 3. And therefore, so we've now proven that f is continuous on its domain from -2 to infinity. So we prove that f is continuous on this because that comes from g. G is differentiable, hence it's continuous on that whole interval. We have to avoid 3 because 3, we got to be careful about that. You got to avoid 3 because 3 is the break point between these two parts. You got to handle that one as a point continuity problem. And since on the right hand side, the function is a polynomial, so we know that f is continuous from 3 to infinity, not including 3. At 3, we got to analyze that one specifically. So we have to do the function at 3, -1, the left limit and right limit at 3, -1, and conclude about the two-sided limit, -1, and write that the function equals the limit, and we're done. It's continuous at 3, therefore we've proven it's continuous at every value from -2 to infinity. All right, see you in the next one.